Hello, video number 3 in our how to use the multimeter series. This one is going to be voltage testing. Let's get straight into it. So we saw in our first video when we looked at the functions of the multimeter that we had two different voltage readings. One was on the left hand side here, VDC or voltage DC, which was 1200 or 200 milli. And all the way around on the right hand side we had voltage AC, VAC, which again was 750, 200 or 2000 millivolts. So let's have a look at testing both voltage DC and AC. I'm not going to go into detail here about the difference between AC and DC. Hopefully if you are my target audience you already know what that is. If you don't, you can learn that elsewhere. But suffice it to say for what we're doing today is AC is what I'm going to get if I test the voltage coming out of the wall socket in my house. DC is the voltage I'm going to get, or the type of voltage I'm going to get if I'm testing something that has a battery in it. And that's going to be our basic difference between AC and DC for today. Let's start with DC voltage. I have a battery here. My battery is going to give me DC volts. As I said, anything powered by a battery is going to be DC, so that should be pretty straightforward to measure that. Remember that when we're measuring voltage, voltage is like pressure, and it's only relevant if it's different. So when I test from one voltage to another, I get a reading from high to low. If I'm testing two things that are at the same voltage, it's not going to give me a reading, it's going to tell me 0. If I test two things that are 230 volts, that's our standard house voltage here in New Zealand. If I test two things that are 230 volts, that's 230, that's 230, my meter will tell me it's 0, because there's no difference between them. All my meter is doing is telling me the difference between two voltages. So it has to be from low to high, one side to the other. Now we know with our battery, it'll have a plus and a minus. This is going to be my plus side. Here with the little button on it, the blank side will be my minus, and in fact this battery helpfully tells me that on the side. Plus end and minus end. And so I should be able to just put this onto volts DC. I know that a standard battery like this is going to be 1.5 volts. That's the voltage that it should be, and in fact that says that right there. And very small writing, 1.5 volts. So I'm going to choose the setting that most closely matches that. I can go with 200 volts, or I can in fact go to 2000 millivolts, which would be 2 volts, but let's try both. So I'm just going to put my meter on one end, one probe on one end, one probe on the other, and see what happens. And I get 1.6 volts on the screen there. That looks about right, 1.6 volts. If I switch over to 2000 millivolts, it's going to give me an extra decimal point, or rather take one away to give me a more accurate reading. It says 1628 millivolts. So that's 1.628 volts. So it's giving me a slightly more accurate reading. For the purposes of what we're doing here, that doesn't really matter. 1.6 volts is good. I've just taken this straight out of a packet, so it should be charged. And I know that if it's above 1.5, then it is. If I was getting 1.4, 1.3, maybe even 1.2 volts out of that, then I would say that this is starting to become useless to me. But 1.6 looks pretty good. Now let's just check one thing here that you may or may not have noticed, that I put the red lead at the plus end and the black lead at the minus end. And let's see what happens if I switch them over. You see on the display there, I'm still getting the same reading, 1627 millivolts, but you'll see there's a negative in front of that. I'm getting negative 1627 millivolts. Now the reason for that is, as we know, direct current is typified by current flowing in only one direction, which means one side is always positive, one side is always negative. If I'm looking at AC, AC is alternating current. That means that the current flows back from one direction to the other in an alternating fashion, which means one side is alternately positive and then negative, and then the other side is alternately positive and negative. If I'm testing AC, then polarity doesn't mean anything. It's going to change from one side to the other. So if I test AC voltage with my meter, it shouldn't matter which side I put my leads in, because it's alternating backwards and forwards, it will give me the same reading. With my battery, however, it is important because my battery is always positive on one side, always negative on the other. So when I do my test, it's either going to tell me that's plus 12 volts if I put my plus side of my meter to the plus side of the battery, or it'll tell me that's negative 12 volts, or in this case, sorry, 1.5 volts. Negative 1.5 volts if I put the positive side of my meter to the negative side of my battery. Is that important? Well, not really. If there was a certain specific use case where I needed to know whether I've got a positive or a negative voltage in a certain situation, perhaps on some electronic items, it might be. If I'm just testing whether my battery's any good, it doesn't really matter, right? 12 volts is 12 volts, 1.5 volts is 1.5 volts. If it's negative or positive, it doesn't change. I switch my meter over and go from a negative to a positive voltage. The actual reading won't change. Let's have a look at testing AC voltage then. I have a extension lead here with a socket, and I have plugged that in. This should be currently live. If I plug something into that, it would start operating. We can see that we've got 3 terminals there. Rather than the 2 we had on the battery, one end a positive and a negative, we've got 3. And if you look really close, you might even make out that there is writing on those terminals to indicate what they are. I believe we have, in fact they're a bit upside down, we have here an L, over here an N, and here we have an E. They're written upside down. I always look at my sockets this way up. I suppose that's because when you get a socket on the wall, that's the way up that they are. So I always think of this one at the top here as the left, this one is the right, and the bottom one is the earth. But which one is which, and how do we know? Let's have a look here. I've got a couple of images here. One is just a socket, the image symbol of a socket that looks more or less the same as the one that we just saw. We have here a physical picture of a double socket outlet such as you would see in your house. And I've labeled which terminal is which there. So the top left one here is the phase, top right is the neutral, bottom is the earth. Same on this one here, top left phase, top right is neutral, bottom one is an earth. You can imagine that a plug is a mirror image of my socket. So if I was looking at a plug, it would be reversed. Right would be phase, left would be neutral. But for a socket, it's always going to be left is phase, right is neutral. And if I'm doing that test with a socket like this, what should the readings be? Well, I've got that here. Phase to neutral will be 230 volts or thereabouts. This is obviously voltage for New Zealand. We might find it's a little bit higher or a little bit lower than that. In most cases it'll be a little bit higher, but it will be something around 230. That's what we consider our nominal voltage. Phase to earth will also be 230. Remember that our neutral and our earth are connected together. If they're connected together, there can't be a voltage between them. And if there's no voltage between two things, then we will see 0, as I said before. If two things are at the same voltage, when I test voltage between them, I will get 0. Neutral to earth, therefore, is 0 volts. So phase to neutral 230, phase to earth 230, phase to earth 0 volts. So let's do a quick test and have a look at that. So I'm going to start with my phase to neutral. So that should be, switch my meter around to volts AC. I'm going to go to 750, you can see there, not 200, because my voltage should be around 230, so that'll be higher than 200. I don't want to do that. I want to make it, select the 750 volt scale. So I go into my phase, that's the top left one. It'll probably be on the right as you're looking at it. Depends if my camera has flipped that on. Oh no, it should be the left. And into the neutral as well. And you can see my meter buzzing, and in fact you can hear it beeping as well. They're telling me that I'm testing a high voltage, and it says 234. 234. If I pop that lead out of the neutral and I go across to the earth, remember that we said that phase to earth should also be 230 volts. So I've left that lead in the phase terminal and I go into the earth terminal. And again, I get the same reading, 234. My meter is physically vibrating. You can probably hear that. And it's also buzzing and lighting up that little light to tell me in as many ways as possible, be careful, that's a hot one. So that's our live to earth or phase to earth. So I'm going to pop that out of the phase terminal, and just to make sure, we should get 0 volts between neutral and earth, but you never know. If somebody transposed something somewhere, so it could be something funny has happened, we could get a voltage between earth and neutral, so it's a good idea always to test that as well. So I just pop that in there. That is testing now between neutral and earth, and we can in fact see that my voltmeter is saying there is nothing there. Well, it says 1 volt, but that doesn't really mean anything. There's certainly no lights, there's no buzzing, there's nothing to indicate there that I have any significant voltage. So I can safely say that my earth and neutral, in this case, are dead. If I was testing for safety and I wanted to turn this off and make sure that it is turned off, then the next thing I will do is obviously turn that off and test again. I'm going to do another video on testing for isolation, but let's just have a quick look. So I've just unplugged that lead off camera, and so if I test again between my phase and my neutral, we should find now that there's nothing there. So I'm plugged in again to the phase and the neutral, and my meter says 0 volts, there is nothing there. Phase to earth, nothing, and of course neutral to earth was nothing. Even when it was live, remains nothing now that I have turned it off. I think that's it for voltage testing. As I said, I'm going to do I'll do one on testing voltage for isolation. So if I need to isolate something in order to work on it, then my voltage test is my most important test there. Obviously, I would test to make sure that the circuit is isolated, test to make sure that I've switched the correct switch, that kind of thing. That's a really important and probably the most important safety test for an electrician, is testing voltage to ensure something is isolated, because anytime we work on anything we need to isolate it first, and of course ensure that it remains isolated for the duration of that work. Otherwise I'll learn a new dance called the funky chicken. It sounds fun, it's not as fun as it sounds. You'll die and it will hurt the whole time that you're dying. Thanks for watching. The next video will be testing for isolation.